In this tutorial, we are going to solve some questions under projectile motion. So I've got a number of questions with me here. So the first question is saying, a duck is thrown horizontally with an initial speed of 10 meters per second toward point P. The bull's eye on a dartboard. It hits at point Q on the limb, vertically below P. 1.19 seconds later, part A, what is the distance PQ? Part B, how far away from the dartboard is the duck released? Okay, now it is very important for us first to come up with a free body diagram. We need first to understand the question, then we come up with a free body diagram. A free body diagram is going to help us to know what is happening in this situation. Okay, so we are going to consider to say here is our duck. Okay, this point here we are going to say we have got a duck here. Okay, now they are saying that this duck is thrown horizontally, not vertically but horizontally, with an initial speed of 10 meters per second, meaning that this velocity 10 meters per second, it is the velocity in x direction. Remember, whenever we're talking about projectile motion, we're talking about two motion. We're talking about the motion in x axis and the motion in y axis. Now, the motion in x axis is the horizontal motion. The motion in y axis, that is vertical motion. Okay, so now they are saying that this 10 meters per second, it is the motion in x axis. When you are throwing something from the top of the building, or maybe from the top, what we have to understand is that the velocity in y direction in most cases is 0. So in this case, this velocity, the 10 meters per second, it is the velocity for Vx and not Vy. Okay, so it was thrown. Now we are going to consider to say we have got a limb. This is our limb here. Okay, now we are going to say this is going to be our horizontal distance, in this case. Now we know that horizontal distance is what we are going to call the range. Okay, so this distance we are going to call it as the range. So this is going to be my range. Now part B is saying how far away from the dartboard is the duck released, meaning they're asking about the range. Okay, what is the distance PQ? Now imagine this point here. Let me just put a dotted line. Imagine this point here. They're saying that from where it was released, this point here is a P. Okay, so this is our point P. Then it falls somewhere there at point Q. Let's say this is point Q, meaning that it started from there, then it was falling all the way to part E here, to point Q. What we have to understand is that the velocity in x direction is 10 meters per second. Now the velocity in y direction, in that case, is going to be 0. Okay, they have not talked about anything about y. So the velocity initially, the initial velocity in y direction is going to be 0. Okay, now from there we can now solve this question. They're saying what is the distance PQ? So the distance PQ, they're just asking about, we have our data. Okay, the initial velocity, it is 0. We can see that since now when we're talking about PQ, meaning we're talking about the motion in y direction. Okay, so meaning that the Vy initial is going to be 0. Since it was going down, the G is 9.8. Okay, what else do we know? We can see that we want to find the distance in this case. Okay, we can say H if you want. We don't know. Our T, we have our T, which is 0.19 seconds. Now, which formula can we use for us to find the distance? We know that we can say D is going to be equal to V initial times T plus half GT squared. We have everything apart from D. Now, this D is the same as, you can say it is S, or it's the same as H, or it's the same as D. You can just put any. Okay? So our distance in that case is going to be, initial velocity is 0, meaning that everything here is going to be 0. We're going to end up having this. So our D is going to be half. Our G is 9.8. our t is 0.19 now squared. Now getting my calculator, I can see that 0.19 squared, 0.1 0.19 squared times 9.8. The answer I find, I divide it by what? By 2, which is the same as just saying times 0.5. Okay, so this times 0.5, because 1 over 2 is 0.5. So I'm getting my distance to be 0.17689 meters. I can round it off and say it's 0.18 meters. As simple as that. So this is my distance PQ. So my distance PQ is 0.18 meters. Okay. Now part B is saying how far away from the dartboard is the dart released. So how far, they're asking about the range, the horizontal distance. So to find the range is given by this formula. So range is given by Vx times t. So the range will be Vx times t. In most cases, they are going to give you this Vx. Okay, but in a case where you have got an angle, that's why now you need to resolve this one into x component, where you're going to say Vx is equal to V cos theta. But in this case, we have our Vx already, which is 10. And the time we have already is 0.9. So we're going to have our range to be equal to 10 times 0.19. So we are going to end up having 0.19 times 10. So this is 1.9. Okay. So our range is going to be 1.9 meters. So that is how far it was from the dartboard. Okay, so that is it for question 1. Number 2, a small ball rolls horizontally off the edge of a tabletop that is 1.2 meters high. It strikes the floor at a point 1.52 meters horizontally from the table edge. Part A, how long is the ball in the air? Part B, what is its speed at the instant it leaves the table? Okay, so now if you can read this question and understand it, you can see that we have got the height of the table, which is 1.2 meters, because they are saying 1.2 meters high, so that is the height of the table. Then it strikes the floor at a point 1.52 meters horizontally. Whenever we're talking about horizontally, the distance, that is the range under projectile motion. Okay, so now we need first to come up with a free body diagram. So this is going to be our free body diagram in this case. So this is the first trajectory where we are going to have the range. Okay, so we have been told that the range is 1.52 meters. Okay, then how high the table is 1.2 meters. Okay, now this small ball is thrown from here going there. Now we can see that when it was being thrown from the top of the table, the initial velocity in y direction, the Vy, the initial Vy is 0. Okay, now we can see that since it was going down, the G is a positive 9.8 meters per second squared. What else do we know? We can also see that we have the distance, which is how high, or the height. So the height in this case is 1.20 meters. What else do we know from here? Okay, we also know the range. We have been told that the range is 1.52 meters. Now the first question is saying how long is the ball in the air. Now to find this, what we have to understand is that we know that distance is equal to v initial times t plus half. So we have plus half gt squared. Now what we have to know here is that we have the distance already, which is 1.2. So I'll put 1.2 here is going to be equal to the v initial in y direction is 0, meaning that everything here is going to be 0. So this part is going to be cancelled, it's going to be 0. We are going to remain with half. The g is positive 9.8. Our goal is to find the time. Okay, so we can see that this is going to be 1.2 is going to be equal to 1 over 2 times 9.8 is 4.9 t squared. What we're going to do now, we are going to divide both sides by 4.9, divide both sides by 4.9. So my t squared will be equal to 1.2 divided by 4.9. Now my goal is to find the value of t. I can get the square root both sides. Okay, to get the square root both sides, I can see that this is going to be t will be equal to the square root of 1.2 divided by 4.9. Okay, now what will be our t in that case? So if I get my calculator, I'll say 1.2 divided by 4.9. Then the answer I get, I'm getting 0.244897959. I get the square root of this one. I'm getting the time to be 0.49487 seconds. I can round it off and say my time in this case of flight is going to be 0.49 seconds, just like this. Or you can say 0.5 seconds, which is just okay. Okay, so the answer for part A is 0.49 seconds. Now we can go to part B. Part B is saying, what is its speed at the instant it leaves the table? Okay, now to find the speed, in that case, it's the same as just finding the what? The horizontal speed. Okay, because we know that when we are finding the range, that formula for finding the range, even the first question we said, to find the range, we need to say the range will be equal to Vx times t. Now in this case, we know that the first question, when we were talking about the range, that v which we had, it was the Vx. So that Vx doesn't change. Okay, the same Vx which you are going to have in the first point, that is going to be the same Vx which you are going to have. So in this case, since we have this range, we don't have, we also have the time. We can find the Vx. That Vx is going to be our our speed. Okay, so in that case, we can say that we have our range, which is 1.52. This is going to be equal to the Vx we don't know, the time we know it, which is we have found the time to say is 0.49. I can divide both sides by 0.49, even here 0.49. So I can see that my Vx in this case is going to be 1.52 divided by 0.49. Okay, 0.49, which is giving me 3.10 meters per second. So in this case, the speed just instant when it just leaves the table, the speed was 3.10 meters per second. So that is it for question 2. Here is our question 3. So the question is saying a projectile is fired horizontally from a gun that is 45 meters above flat ground, emerging from the gun with a speed of 250 meters per second. But A, how long does the projectile remain in the air? But B, at what horizontal distance from the firing point does it strike the ground? But C, what is the magnitude of the vertical component of its velocity as it strikes the ground? Now it is very, very important for us to understand the question again. So the question, as we can see, this is still the first trajectory where the gun was shot from the top of the building. Okay, so we can come up with a free body diagram. So they are saying that the gun was shot from the top of the building. Okay, so it was shoot from the top of the building. Let's say here is our gun. So it was shoot from the top of the building until it falls there. Now, what we need to understand here is this. When the gun was being shot here, this velocity which have been given, it is the velocity in x direction. Okay? Whenever an object is coming from the top of the building here, its initial velocity is 0. That is very, very important. Now, that 0 which we're talking about, it is the velocity in y direction. Okay? So in this case, we have the Vx, which is 250 meters per second. And then we also have the Vy, which is 0 meters per second. Okay? So the velocity which it was using, the velocity in y direction it was 0. The velocity in x direction it was what? Remember, whenever we're talking about the projectile motion, the object is moving in both x and y direction. Okay, that is the reason why projectile motion is considered to say it is a motion in 2 dimensions. Okay, now the first question is saying how long does the projectile remain in air? This is the same question. This is question 2. We are solving the same question. Okay, so how high the building was is 45 meters. Then we need to find again the range. The range we don't know. Okay, so the first question is saying how long does the projectile remains in air? Remember, we are using the y, so we're going to say that d is going to be equal to v initial times t plus half gt squared. Now, which v are we talking about? We're talking about the velocity in y direction. Okay, now the velocity in y direction, the initial velocity in y direction is 0, and we know that this is 45. So we're going to say 45 here is going to be equal to, this is going to be 0 plus half. Since it's coming down, the value of g is going to be positive 9.8. Then the t is the one we are trying to find. So we're going to say 45 is going to be equal to 1 over 2 times 9.8. This is going to give me 4.9 t squared. We'll divide both sides by 4.9, both sides by 4.9. We can see that t squared will be equal to 45 divided by 4.9. We get the square root both sides. We can see that t will be equal to the square root of 45 divided by 4.9. Now you can first find this if you want, and then take a square root both sides. You're going to find the same answer. So in this case, my t is going to be, so my t will be equal to the time it was in air is going to be 45 divided by 4.9. Now I get the square root of this one, so I'm getting 3.03. So 3.03 seconds, that was the time it was in air. Okay, now part B is saying at what horizontal distance from the firing point does it strike the ground? As long as they're talking about the horizontal distance, just know that we're talking about the range. Okay, and we do know that the range is given by Vx times t. So our range is going to be Vx times t. In this case, our Vx is 250 times the t is 3.03. So our range in this case is going to be 250 times 3.03. So this is giving me 757.5. So 757.5 meters, that is the range. Okay, so the last question, let me just put the range here to create space, and then let me put the time here, which is 3.03 seconds. So I'll get rid of this. Now part C is saying what is the magnitude of the vertical component of its velocity as it strikes the ground. They're talking about the vertical component, meaning we're talking about now the velocity in y direction. Okay, so now what we need to understand is that when it was starting moving from this point, the Vx, this is the initial velocity for y, is 0, but as it is coming, the velocity was increasing. Now they want us to find that the magnitude of that velocity just before it hit the ground. Okay, so now we can see that we can use this formula to say V final. Now we want Y is going to be Vy initial plus GT. Now we can see that we are trying to find this, okay? And we know that we have the initial already. Initial is 0. So we are finding Vy final to be equal to, this is 0 plus, G is coming down, is going to be positive. Then the time, we know that it is 3.03. So my Vy final will be equal to 9.8 times 3.03. So this is going to give me a 29.694. 29.694 meters per second. That is going to be my vertical component of the velocity just before it hit the ground. So I can round it off and say this is going to be 29.69 meters per second. Okay, so this is the velocity just before it hits the ground. That is the vertical component, the y component, just before it hits the ground. It is totally different from the question when they ask you to say what is the velocity just before it hits the ground. So that one you have first to, we have the Vx and we have found the Vy. You need to find now the magnitude of the velocity. But this question is saying what is the magnitude of the vertical component of its velocity as it strikes the ground. So they just want us to find the vertical component, which is the y component. Okay, so that is it for question 3. Number 4. In the 1991 World Track and Field Championship in Tokyo, Michael Pau jumped 8.9 meters, breaking by a full 5 centimeters the 23-year long jump record set by Bob Beon. Assume that Pau's speed on takeoff was 9.5 meters per second, about equal to that of a sprinter, and that G is 9.8 meters per second in Tokyo. How much less was Pau's range than the maximum possible range for a particle launched at the same speed? Okay, now let's get to understand this question. So they are saying that how much less was, so in short they're just asking us to find how much less was the range than the maximum possible range of the same particle launched with the same speed. Now what we have to understand here is for someone to have maximum range, or if you are trying to reach at the maximum range, meaning that you have to launch a ball at an angle of 45 degrees. Okay, so what I'm trying to say here is this: if this is the ground, if you want to reach at the maximum range, you have to launch this ball at an angle of 45 degrees. Okay, so if you launch this ball at an angle of 45 degrees, you are going to reach at the maximum range. So it's going to go there all the way up to here. That is when you can have the maximum range. As long as you launch any object at an angle of 45 degrees, you are going to have the maximum range in that case. Once you launch the ball less than 45 degrees, what you have to expect is you are going to have something like this. A ball is not going to have the maximum range. You launch the ball there, it's going to reach maybe somewhere here. At the same time, if you launch a ball at an angle of greater than 45, it's going to reach there. Okay, so for you to reach at the maximum range, the ball or any object is supposed to be launched at an angle of 45 degrees. That is very, very, very important. Now, if we can read this question carefully, this question is saying this person, he jumped 8.95 meters. So if you can think, is this the vertical distance or horizontal distance? They are saying that breaking by a full 5 centimeter. So this was just the record which this person was breaking. Now they are saying that it is long jump. Now if you think of long jump, meaning that is what the horizontal distance, so that is the range. So now they're saying that this person, the range which this person jumped, that was 8.95. Now the question is saying how much less was Paul's range than the maximum range. Now we need just to find the maximum range. Once we find that maximum, for example, let's say this range which this person which spouse jumped, maybe it was somewhere from here all the way to there, maybe that range is what, 8.95 meters. Now they want us to find how much less it was to the what maximum range. So they're just trying to ask us to find this range. Now we need to find the maximum range. After finding that maximum range, we're going to do minus the possible range which this power jumped, then that is going to be how much less it was for it to reach at the maximum height, the maximum range. Now what we can do here is we need first to find, for us to find the range, we know that range, that will be now the maximum range, is going to be Vx times t. Now in this case, since we're talking about the angle, is going to be V cos theta times t. Now this t, it is the time it took for the ball to be launched from this point all the way to the ground again. Now to find that time, we know that we can use this formula. Okay, V final, in short, let's say Vy final is going to be V initial Vy initial plus gt squared, or it's just gt and not squared. Now we know that we're talking about the angles there. So whenever we're talking about the Vx, let me just do this. I create space here. We have this now. Okay, that is the V which we have. So this V is going to have the vertical component, the horizontal and the vertical component. So the angle here is now 45 degrees. So this is going to be our Vx, this is going to be our Vy. We know that Vx is going to be V cos theta. Okay, Vy is going to be V sin theta. Now our trajectory is in this order. So it's coming from here all the way to there. Now we know that whenever it reaches at the maximum height, the final velocity at that point is going to be 0, meaning that this point here is going to give us 0. Okay, so we're going to have 0 here. It's going to be equal to, this is going to be V sin theta because it is in y direction, then plus the g is going to be negative because it is going up times t. Our goal is to find the value of t. What I'm going to do here is I'm going to shift V sin theta to the left hand side, then we're going to have negative V sin theta is going to be equal to negative gt. Let's divide both sides by negative g, even here by negative g. Our t is going to be equal to V sin theta, everything divided by g. Now from here what we have to understand is we're going to have this now. Okay, this t, if we check our trajectory, this was our trajectory. So starting from this point all the way to this point. Now let's call this point to say point A, this is point B, okay, then this is point C. This is the time from A all the way to B. Now to find the time for us to find this time, we need to get the time from A all the way to C. To get the time from A all the way to C, we need just to do times 2 this equation. That will be the time now from A to C. So this time from A to C, we can see that is going to be 2 V sin theta, everything divided by g. Now let's try to plug in the values. We see the t which we are going to have. Okay, so in this case we can see that our t is going to be equal to our 2 times v is 9 point, the one which we have been given, it is 9.5. Then we have sine the maximum is going to be 45. We divide it by 9.8. Okay, so we can see that our time in this case is going to be, what is 2 times 9.5, that is going to be 19. So what is 19 sine 45? Then we divide it by 9.8. So this is giving me 1.37 seconds. So that was the time it was in air. So in short, that would have been the time it would have been in air for it to reach the maximum range. Okay, now we know that for us to find the maximum range, we know that the formula is going to be we're going to have a formula which is going to be, the range is Vx Vx times t. Now Vx is v cos theta times t. Now we know that the v is 9.5, cos theta, which is the maximum, is going to be 45 times t, which is 1.37. So our maximum range would have been what? We're going to say 9.5 cos 45, then the answer I find times 9 or 1.37. So I'm getting my answer to be 9.20 meters. So this would have been the maximum range. So in short, this would have been the maximum range if Mike would have been reached at the what? The maximum. Okay, so this would have been our maximum range. Now they are saying how much less it was. Now what we have to understand here is this. Okay, so this Mikhail jumped that the range which Mikhail had, it was 8.95 meters. Now the maximum range he would have had, that would have been 9.20 meters. Now for us to find how much less it was, we need to say this minus the range which Mikhail had. So that is going to be, we need to say 9.20 minus 8.95. So we are going to get 9.20 minus 8.95. So we are getting 0. So how much less it was is going to be 0.25 meters. As simple as that. So that is it for question 4. Question 5. The current world record motorcycle jump is 77 meters set by Jason Lenny. Assume that he left the takeoff lamp at 12 degrees to the horizontal, and that the takeoff and the landing height are the same, negating air drag. Determine his takeoff speed. Okay, so we are trying to find the initial speed in short. Okay, so now let's assume to say this is the type of trajectory. The second trajectory, where you start from the ground. Okay, so he jumped from here, so this is the takeoff. Now from there, from this point all the way to this point, so we have got what we call the range. Okay, so and this range we have been given. They are saying that given that he jumped, that is 77 meters. So that 77 meters is the range. So we have our range in this case to be 77 meters. Now they are saying that the takeoff and the landing height are the same. Okay, so meaning that even the maximum height which we are going to have here is going to be the same as the range. Okay, but anyway, we are not interested in what height, so we can just see that if we have the range here as 77 meters, they want us to find, we have the theta, they want us to find the speed, but we know that the formula for finding the range in that case is going to be range is given by Vx times t. Now if it was at an angle, we do know that range is going to be Vx is going to be v cos theta. So v cos theta times t. Now the time, when it comes for this time, we do know that whenever we are talking about the time, this time from this point, okay, to calculate the time from this point all the way to the maximum height, this is the formula. Okay, t will be equal to v sine theta over g. But now what we have to remember is that since we want to get the time from this point all the way until it reaches down here, meaning that the time now we need to do times 2. So this is going to be our formula for the time it was in air. So now I'm going to replace this time there to say range will be equal to v cos theta times the time is 2 v sine theta, then I divide it by g. Okay, now this one, if I can simplify it, I can say v times v is going to be v squared Okay, so I'm going to have 2 here. Then I'm going to have sine theta times cos theta. I divide everything by g. Now there is this thing which we need to understand here. This is an identity. So we have 2 sine theta cos theta. This is the same as sine 2 theta. So this is an identity. So where you see sine 2 theta, you can replace it with what? 2 sine theta cos theta. So now the whole thing here, everything, this part here, I'm going to replace it with what? Sine 2 theta. So I'm going to have my formula range to be equal to v squared. Then I'll have sine 2 theta divided by g. Perhaps you have seen this formula for finding range. Okay. Now this is the same formula which we're going to use for us to come up with what? The initial speed. So I'll get rid of this. I'm going to say my final formula now for range is going to be the range will be equal to v squared, okay, sine 2 theta. Okay, then we divide it by g. But we know we know the theta which we have. So we're going to say range we have been given. Okay, my goal is to make v as a subject of formula. I'm going to cross multiply. I can see that I'm going to have v squared sine 2 theta will be equal to the rg. So I can divide both sides by sine 2 theta, even here by sine 2 theta. So these two, they will cancel. So I'm going to remain with v squared will be equal to the rg divided by what? Sine 2 theta. Now from here I can get the square root of both sides. Okay, therefore my v will be equal to, it's going to be plus or minus, but we want to get the positive, so I'm going just to say the square root of rg everything divided by sine 2 theta. Now let's plug in the values. We plug in the values, we see the velocity which we are going to have. That will be our initial velocity, the takeoff velocity. So v will be equal to, so we have the range as 77 times 9.8. We divide it by sine 2 times the angle 12. So it's the same as the angle now inside there is going to be 24. Okay, the angle is going to be 24, then it's going to be sine 24. So we're going to have v will be equal to, so you're going to say 77 times 9.8. So I'm getting a 754.6, everything divided by sine 24, because 12 times 2 is 24. So I get the square root here. Okay, so 754.6 divided by sine 24, and then I get the square root. So I'm getting my velocity as v to be equal to 43.07, which is the same as 43.1 meters per second. So that is it for question 5. Then we have a question 6, which is saying a stone is catapulted at time t is equal to 0 with an initial velocity of magnitude 20 meters per second and at an angle of 40 degrees above the horizontal. What are the magnitude of the horizontal and vertical component of its displacement from the catapult site at t is equal to 1.1 seconds? Repeat for the C and D vertical component at t is equal to 1.01, and for the E horizontal and vertical component at t is equal to 5.00 seconds. Okay, so in short, they want us to find the vertical and the horizontal displacement, the magnitude. Now let's see how we can solve question 7, which is saying a certain airplane has a speed of 290 kilometers per hour is diving at an angle of 30 degrees below the horizontal. When the pilot releases a ladder decoy as shown in the figure below, the horizontal distance between the releasing point and the point where the decoy strike the ground is 70 meters. So they're talking about the range now. Part A, how long is the decoy in the air? Part B, how high was the release point? So we also have question 8. Now let's see how we can answer question 8. So question 8 is saying, so here's a question for you. Upon spotting an insect on a twig overhanging water, an anchorfish squeezes water drops at the insect to knock it into the water as shown below. Although the fish sees the insect along a straight path at an angle phi and a distance d, a drop must be launched at a different angle theta. If its parabolic path is to intersect the insect, if phi is 36 degrees and d is 0.900 meters, what launch angle theta is required for the drop to be at the top of the parabolic path when it reaches the insect?